purpose of this video is to explain Euclid's division algorithm. And the point of Euclid's division algorithm is to find the greatest common divisor, or greatest common factor of two numbers. And it's a really pretty neat algorithm, and I want to explain why it works, because you're going to use it in an interesting way to then figure out some inverses, mod 29s for your matrices. And to explain Euclid's division algorithm, I have an example here. What's the greatest common divisor of 6,300 and 182? And the first step in Euclid's division algorithm is to express 6,300 in this case as multiples of 182 with a remainder. And so that's what I've done here, right? 6,300 is 182 times 34 with 112 left over. And right now, what I'm about to say is the heart of Euclid's division algorithm. If 6,300 and 182 have a greatest common divisor, then that greatest common divisor must not only be a factor of 6,300 and 182, but it must also be a factor of this remainder. And you need to think about that and make sure that makes sense to you, and I'll try to explain it in a different way. If 6,300 has a divisor, let's say the greatest common divisor of 6,300 and 182 is D. Okay, so that means we'll say that 6,300 is the same as let's say A times D. Okay, whatever D is, when we multiply it by A, we get 6,300, and we'll say that 182, of course, is also a multiple of D because it's their greatest common divisor. We'll say 182 is B times D. Okay? And we'll call 112 R for the remainder for now. Now look at that equation. If D is a a divisor of 6,300, and D is a divisor of 182, well, in order for this to be true, this equation to be true, then R must also be divisible evenly by D, because D is a factor of this side, which means D has to be a factor of this entire side. So there must be some C value that we can multiply D by to get R, because we need to be able to factor out that D in order for this side to also be divisible by D. And so Euclid's division algorithm is really kind of ingenious, right? Because what it says is, okay, I've got a greatest common divisor. I don't know what it is yet, but if I divide 6,300 by 182, then the remainder is also going to be divisible by the greatest common divisor of 182 and 6,300. Okay? And so that's the starting point. Let me clear these off. Where we go next is to express 182 in terms of 112, because if 6,300 and 182 have a greatest common divisor, then that divisor is also the greatest common divisor of 182 and 112. So we say 182 equals 112, in this case times 1, plus a remainder of 70. And for the same reason that the greatest common divisor is a factor of 112, it must also be a factor of 70, because it's a factor of these two things, and so it must be a factor of these two things. And so we repeat the process. 112 is 70 times 1 plus 42. And again, for the same reason, the greatest common divisor of 6,300 and 182 is a factor of 112, but because it's a factor of these two, it's a factor of 70, but because it's a factor of 70, it's a factor of 42, and so on. And so we keep going. 70 is 42 times 1 plus 28. (42) is 28 plus 14, and we come to the last bit where 28 is 14 times 2 with no remainder. This tells us that 14 is the greatest common factor of 6,300 and 182. This final remainder before the last one that's going to be 0 is the greatest common factor of the original two numbers. And it's a very neat little algorithm for finding the greatest common factor of two numbers. We're going to use it in a unique way to figure out the inverses. Thank you.